Okay, so I did 6 versions of this problem. I did each of R1, R2, and R3 rotated about each of OA and AB. Those are the ones that you can easily check on your own, so I felt like they'd be the most helpful. Let me know if you need help with any other solids, finding volumes of any other solids using these pieces. You're going to use that formula right there, the integral from a to b of a of x dx, or the integral from c to d of a of y dy. The big key aspects here are you're going to use the equations of your boundaries, which in this case is y equals the fourth root of x, and y equals x, that's actually this line right over here, to convert from x's and y's and y to x's whenever you need that. If you're going to be using this one, and you need to convert to y's, you're not going to use just y, you're going to say that x is equal to y to the fourth, and then use that. So okay, let's just do OA. Yeah, okay, so R1 rotate about OA. Let's just take this representative point right over here. So what's that point right above there making the radius? It is, if this is x0, this point right over here is xy. So the radius has the magnitude of y. But again, we want x's. So we're going to use the equation of the line, which is y equals x, to convert to radius of x. Pretty easy to evaluate. R1 about AB. So R1 about AB. So what's this radius here? If you have this representative point is 1y, this representative point is xy. So we've got a distance of 1 minus x, but again, we want it in terms of y, so we say 1 minus y squared. Easy to integrate, no problem. R2 about OA. So R2 about OA. Alright, so this is the first time where we gotta subtract away a small disk from a big disk. We're going to take a big disk that's going to be this entire distance here, so it's going to have a radius of 1. We're going to have literally pi 1 squared minus pi, and the area bounded by this curve would give us a radius of, that would be a disk that would subtract all that volume away, right? So the equation of this line is just fourth root of x, and what we want is in terms of x, so we would just say pi 1 squared minus pi fourth root of x squared. And in fact, that's almost what I did. I just factored out the pi, but otherwise it's the same thing. I kept it in terms of exponents, the radical, because that's easier for me to integrate, but pi by 3, pretty easy stuff. R2 about AB. So R2 about AB. So in this case, right, we've got that same boundary here, but we want this to be in terms of y, so we're not going to use y equals the fourth root of x. We're going to say that x is equal to y to the fourth. So it's going to be a big radius, which takes into account everything, which is just 1. So we have pi 1 squared minus, so what's the radius of this part that we want to take away, the region that includes R1 and R3? Well, we start further to the right and go to the left. So this is 1 minus y to the fourth. So we should have pi 1 squared minus pi 1 minus y to the fourth quantity squared. And that's exactly what we get. This, not very difficult to integrate. You just got to make sure to expand this guy. The constants cancel, although they didn't need to. It's just a polynomial that's easy to integrate and evaluate, so no problem. So R3 about OA. R3 about OA. Okay, so in this case we've got 2 lines that are boundaries, so we're going to have 2 bits of variables in there. So it's going to be, everything's already in terms of x's, so no problem. We're just going to say pi fourth root of x squared minus pi x squared, and I bet I factored out the, yeah, pi, I did. Okay, again, I just kept it in terms of exponents so that's easier to integrate. And we've got our last bit is R3 about AB. R3 about AB. So yeah, this would be the most difficult one, I'd say, out of what we got. But nothing has been so bad, right? So we're going to have, again, this bigger radius, the distance from here to here, minus the smaller radius. So we'd have a big disk, and we'd subtract away the smaller disk. Sounds like shells, right? Yeah, that's kind of what they're building you up to. So what's the distance from here to here? That should be 1 minus y to the fourth, because remember, we're doing it in terms of y. So pi 1 minus y to the 4th quantity squared minus pi was the distance from here to here in terms of y. It should just be 1 minus y. So pi 1 minus y quantity squared. So those two things subtracted, the bigger one minus the smaller one. Let's see if we got any luck. So pi 1 minus 4 squared, yep. Again, you gotta expand this guy, and then you just get a polynomial. Easy to evaluate. Alright, let me know if you need help with anything. You should be pretty good with this stuff, though. Have fun.